All right, so we're gonna, like I said, talk about all of the functions we've been learning about. By the end of today, you're gonna have a whole plethora of functions in your back pocket that you're gonna know. All we're really gonna do today is talk about domain, range, increasing and decreasing, intercepts, mins and maxes. All these things should sound familiar because we've covered what they mean. Today we're just now going to actually find all these different values and intervals for different functions. Okay? The first one is pretty simple. You've seen it since middle school. Linear functions, right? That y equals mx plus b form. Okay? The domain is obviously all real numbers because we're going on and on forever in both directions. So range is also all real numbers. Our x-intercept is always my y, negative of my y-intercept divided by my slope equals 0. Okay? And obviously, if my slope is positive, we're increasing. If it's negative, we're decreasing. If it's equal to 0, we're constant. Okay? Yeah.
Can I get my packet?
Yes, you may. Go ahead. Let's just practice, refresh ourselves. This was on 2.1, but I just want to make sure we all know how to do this because you might see it. Wink, wink. Here I have number 1 here. It says write a linear function. When I'm asking you to write a linear function, that's my fancy terminology to really find what? What do we mean when we say that? Yeah, just an equation, okay? That's just the fancy way of saying equation. Okay, so write a linear function f for which f of 1 equals 3. So in other words, I know that I need to have a 0.13. And f of 4 equals 0, so I know that I have 4, 0. Okay, so I have those 2 points. What's a very important piece of information that I need to write an equation? Very important part of our y equals mx plus b form. A slope. There you go. y1 minus y2. Okay, perfect. So we're going to do, I'll do 0 minus 3 over 4 minus 1. So I have negative 3 over 3, which simplifies to negative 1. Okay, that's my slope. Okay, that's my m value. Now there's kind of 2 ways you could go about finding our actual equation. The point slope is probably the easiest one. Okay, so remember point slope, I have y minus y1 equals m times x minus x1. So I'm going to plug in my slope. And then it doesn't matter which point you pick, but I'm going to pick this one. Why do you think I'm choosing that one? Yeah, because of that 0. Because when I plug in this minus 0 here, it's going to make my life a lot easier. Okay. Again, you totally could have picked the other point. It just would involve some more work trying to get y by itself. Okay? But because I'm subtracting by 0, I really already have y by itself. I'm going to distribute my negative 1. So I have negative 1x plus 4. Okay? Okay, and that was like 2.1 stuff, but just to make sure we refresh ourselves on that. Any questions? All right. Now, special types of linear function, there's 2 of them, okay? One of which is a constant. The c here is referring to like a number, so no variable, we just have a number there. And then my identity function, which is a vertical line, all it equals is my variable x. Okay, so these are going to be some information you want to write down. My constant. You guys have all seen this before. This is that straight horizontal line. My domain for that is going to be negative infinity to infinity because I'm going forever and ever in both directions. My range is the difference here. My range is only one number. Okay? It's whatever that constant is. And its graph appearance is that horizontal line. Oh, I know that's a little small to see. Let me zoom in a little more. The identity function, you guys have probably seen it a bunch of times. We've just never named it. Okay, my domain and range are both negative infinity to infinity because I'm going both directions forever and ever. The graph appearance, diagonal line. Now, it is only the identity if it goes through the origin and its slope is 1. Okay? So if we had a 2 out front of the x, that would not be identity anymore. Okay? So that's why I specify slope equals 1, y-intercept is 0, 0. Okay? We're going to see a bunch of graphs today. For graph appearance, this is the only one that has like specific numbers that go in that spot. Okay, the rest of them don't really. We'll just kind of describe what we see. All right, so I don't need another minute here. Okay. All right, so now we're going to go through, like I said, a bunch of different functions today and just apply what we've been talking about this week. Okay, so here's a list of everything we've gone over this chapter. We're now going to apply finding those to each of these functions. So first we're going to talk about quadratic functions. Okay, remember quadratic is anything with a highest degree of 2. Okay. Our picture of our graph is over to the side. You guys have seen this in Algebra 2. Remember, it also could be down, right? If we had a negative coefficient, it would just flip it upside down, but it's still a quadratic. Okay. My domain, those arrows at the end mean I'm going on and on forever. So my domain is going to be negative infinity to infinity because my x values don't have a limit, right? They're going on and on. My range, however, we now see is not negative infinity to infinity. The lowest x value on this graph would be what? 0. And 0 is included, so let's put a bracket around it. And it's going up to infinity. Okay, so that's my range for this one. Okay, now think back to even, odd, or neither. Remember, what are we looking at to determine even, odd, or neither? Okay, same or opposite algebraically. We could totally do it that way. Remember, we'd plug in a negative x here. You can also tell by looking at our graph, though. What am I looking for in my graph? Yeah, we're looking for symmetries, right? Where is this symmetrical around? What axis or origin? Yeah, the y, which tells me it's what? If it's symmetrical about the y, what is it? Even, odd, or neither? Even. Perfect. Okay, so today we'll have a little built-in review. Okay, so this is even. We also kind of answered our second part, right? Its symmetry is about the y-axis. Okay, so that's why I'm writing both of these in blue. Okay, because they're very much related. You answer one, you kind of answer both. Yeah, Colin.
Wait, what's the even, odd?
That means we talked about, I think it was Tuesday. Was it yesterday? Wow, time's going slow. If it's either symmetrical about the y, it's even. If it's symmetrical about the origin, it's odd. Or we plugged in the negative x here. This is what we did those exit tickets on yesterday. Okay, we're not really going to go into what it means to be even or odd. It's basically just compare. It's another way of thinking of symmetry. Okay. My intercept, where it crosses my x-axis, my y-axis is 0, 0. Okay, so where it crosses my y is my intercept. And now when we talk about increasing or decreasing, remember we're thinking about intervals. Okay, so if I look at this quadratic, remember we go left to right. So on the left side is where I'm decreasing. Okay, so I would say decreasing from negative infinity to 0. And remember, when we talk about increasing or decreasing, we're never going to have brackets. Okay, ever. Even if it does seem like 0 is included. Okay, this is really a turning point. So just for the sake of keeping life simple, just think no brackets for increasing or decreasing intervals. Okay? All right, so then let's go look at my next interval. From 0 to infinity, we are now increasing. Okay? And I'll tell you right now, we're going to see some examples today where it's only doing one or the other. Okay? This one we see both increasing and decreasing happening. Okay? There's some graphs where it's just decreasing and some graphs where it's just increasing. Okay? You don't need both. All right, where is my maximum or minimum on this graph? Yeah, at the 0, right here. So my minimum, we would say minimum at 0, 0. So you're going to tell me if it's a max or min, and if it's at 0, 0, okay? And not all of our functions will have a max or min either, okay? So some of these we won't even talk about. All right, and then last but not least, graph appearance. I'm just going to say U shape, okay? There's really no, totally correct answer, but if you were to say here a straight line, I would say that's wrong. But if you wanted to describe it as something else, you could have done that too. All right, so this is kind of the gist of what we're doing today, is going through each of these. Any questions on our first one? All right, try our second one. I'm providing you the picture. So here's our cubic root. Okay, not root, sorry. Our cubic function. Here's what it looks like. I'll zoom in a little more so it's a little bigger. Once you have it drawn, I want you to now go through all the different pieces and see if you can figure it out. All of our pieces.
Wait, if it's increasing, do we have to specify?
If it's increasing over the whole thing, do the negative infinity to infinity. Yeah.
Like, would the domain and range be the same?
The domain would, but not the range. Because think about what y values am I seeing in this graph?
Negative and positive?
Negative and positive versus up here, I started here and I only went up. What do you notice about my y values here?
Decreasing or increasing?
Right. It's all of them, right? Because we're going on and on forever up here, on and on forever down here.
So do I say like the same thing? But do I put...
Nope, you don't need that one because that one was starting at 0, going up only.
I don't know how to describe this shape.
The shape, yeah, this one's hard to describe. This one's hard. All right. So here's what we should have gotten. Our domain and range are both negative infinity to infinity. Okay? Because we're going on and on in both directions. We're getting farther and farther apart, and we're getting farther and farther apart north to south. Okay? This one is an odd because it's symmetrical about the origin. Okay? My intercept is 0, 0, just like the last one. Notice I'm increasing only in this one. And I also told you my interval, negative infinity to infinity. Okay? Graph appearance, sideways S. I've had somebody tell me it looks like a snake. That works too. Okay? I'm not going to be picky about that description as long as I see it. Okay? Any questions on this one? Okay. All right. All right, let's look at our next one. This one is our square root function. Okay, so it looks like this. Okay, because we're dealing with only real numbers. So go ahead, graph it, and then I want you to come up with these different forms. Yeah. This is you can write snake or whatever. This one won't be on the test.
And then, why is it only increasing?
Because we're going up, and then we go up just not by as much, but we're still going up the whole time, even right here.
Because this like stops.
Right. We changed directions that one.
So for symmetry, would it be like none?
Mm-hmm.
Curve line, right? Curve line. There's a clash.
All right. Let's see how we did on this one. So we should have had a domain and range. Both started at 0 but included 0. So they both had a bracket. And we went on to positive infinity. We've got, it's not even or odd. And there's no symmetry. So we write none. Okay. Intercept is 0, 0. And we're only increasing from 0 to infinity. And again, no bracket. Even though this 0 is included, okay, we don't put a bracket when we talk about increasing or decreasing. Graph appearance, I just said half arc. Okay. I probably won't ask you to describe a graph on a test like this. Okay, so don't stress over coming up with a perfect description. Okay, this is more for you in terms of studying. Okay. All right, any questions on this one? All right, our next one is going to be a little harder, okay? So here's what I drew. Now, I'm going to actually switch over to Desmos here in a second, but I'll let you copy this first. Okay, because as people, we are not perfect, okay? My drawing is not perfect, and I'll show you on Desmos what's really happening here, because you're going to need to know this when you try to make find my pieces. So, I'm just going to switch, like I said, over to Desmos. Here's what our graph looks like, okay? This is what's happening. If you notice in each side, okay, here I am close to the x-axis. That's what this is. Notice my red line is getting closer and closer and closer, but is it ever hitting that x-axis? No, okay? Same on the other side. Look at my y. I'm getting closer and closer, but am I ever hitting that y-axis? No. Okay? So that's going to be important when you go to write my domain and range and intervals for increasing or decreasing. Okay? So know that in this graph, my lines will never touch my x or y axis. Okay? All right, knowing that, go ahead, see if you can come up with all my pieces. No solution? What do you mean?
No symmetry.
Oh, no, this one has symmetry.
The order.
Mm-hmm.
What the intercept thing? Is it no cross it?
None.
So do we still write 0 for like the increasing and decreasing?
Yeah. Still use 0.
Wait, so we're not going to need graphic arrows on the test, right?
Yeah, in terms of describing with words. No. Hold on. Some people are still working back there. You all what? All right. Okay, so my domain and range are almost everything. Okay, but both of them exclude 0. So we've got to show that break here. Okay, so they're going up to 0 for both of them. Okay, but it doesn't include 0.
I don't understand.
Okay.
I need some more in-depth, tutorial
On Y? Well, remember how I showed you on Desmos? We get closer and closer here, but we don't actually touch it. That means domain is not in my function, which makes sense, because what can I not divide by? What can't be in the denominator? 0. Okay? So 0 cannot happen, right? That's why we don't have 0 in my domain. Can I, if I have a 1 up here, 1 divided by anything, does that give me 0? Is that possible?
What?
Can I do a 1 divided by something to get 0? No, so that's why it's not included in my range. Okay? All right, it's odd because it's symmetrical at the origin. If I were to fold this diagonally, it would match. Okay? The increasing and decreasing is, in my opinion, the hardest part. Okay? Because we're technically decreasing the whole time. Okay? It's very, very gradual, right? Like right here, I mean, we're going down like millimeters at a time. Okay, then we pick it up and then we become super steep, but we're decreasing. If I start up here, I'm decreasing pretty fast, but then it levels off, but I'm still decreasing really slowly. Okay, so in my opinion, this is the hardest part of this one, is recognizing that it's decreasing the whole time. Again, you got to account for that break though. Okay, we can't just say it's decreasing negative infinity to infinity. And then I just said mirrored use, but yeah. This one, yeah, this one's the trickiest one. We'll go back and look at it later, you and I, if you need, okay? All right. Any questions on this one? I think this is our last graph we've seen before. The last thing we're going to talk about today is the greatest integer function. Now, I could be mistaken, but those of you who took Algebra 2, did you guys talk about this? Did you see this notation before? Okay. I thought this was new. I just wasn't sure. So we're going to talk about the greatest integer function today. It's also known as a step function. You'll see why. Okay? You've probably seen the graph before, but now we're actually going to name it. Okay? So you might hear me refer to it as step function, but the official name is greatest integer function. Okay. The name greatest integer function will help you actually solve these functions. Okay. And my definition is really helpful here. F of x equals, this funky notation is not an absolute value. Don't confuse it with that. Okay, it's also not just a bracket. That tells me greatest integer. This whole thing equals whatever integer is less than or equal to what's inside it. Okay, so we'll see what that looks like in a second. So my f of x equals my funky notation here. My answer is always going to be an integer that's less than or equal to whatever's inside this. Okay? So whatever integer. Now, good question. Integers. Those are all my, like, nice numbers on a number line. So, like, 38 would be 1, but my negatives are also included. Like, -1, -2, -3. So no decimals. No decimals or fractions.
So any whole number.
Basically whole numbers, okay? But we include the negatives. That's why we say integers, okay? So this little piece right here might help us out, okay? So here, oh, that's like real blurry. Let's see if I can zoom out a little more. So here's like the first one right here. My -1 is inside these funky brackets, okay? -1. The integer that is less than or equal to that is just -1, okay? If it's already an integer, whatever that integer is my answer, okay? So if there's an integer inside, it just equals that integer, okay? So for example, if I had another one, if I had 5, my answer would be 5, okay? So when it's an integer, it's nice and easy. Here's where it gets a little harder, okay? I now have the greatest integer of -1/2. If I were to think about this on a number line, here's -1/2. Here's my 0. Here's 1. Whatever integer is less than or equal to this. So the first number I get to when I'm going down is -1. So my answer is -1. Okay? What about 1/10? 1/10 is technically, if I were to extend this, here's 1. 1/10 is like right there. Again, think rounding down. That can be helpful. Round down. So if I'm at 1/10 and I were to round down to the first integer I hit, it'd be 0. So my answer is 0. So your answers to these problems are always going to be nice whole numbers. Okay? Same with this one. 1.5. If I'm at 1.5 and I round down, what's the first integer I hit?
1.
1. So my answer is 1.
Wait, but if it's 1.5, should we round?
Yes, so you think you should, but for greatest integers, we always go back. Always go back. Always, yep. Even if it's, I could have 1.9999999 and it would still be 1. Okay? Think about like Price is Right, right? You want to hit it without going over, okay? All right, so here's what our graph looks like. So again, you might have seen this before. This is why it's called a step function. Don't feel like you have to graph all these. You can just do like 3 just to get the idea. Okay, but these are going to go on forever and ever and ever into eternity. Okay? This is why it's called a step function. Looks like a bunch of steps. Okay? Here's why this makes sense. Okay? I'm going to pick, if I look at in this little interval right here, my x values. All of these values right here are my decimals. Okay? However, wherever I am in this interval, I'm rounding down, and I'm going to hit 2. That's why all of these x values share the y value of 2. Okay? We have an open circle here just to show that it's going up until we hit that number, but then we have to step up because now we've hit that next integer. Okay? On the test, you will not be asked to graph this. Okay? You will not be asked to graph this, so don't panic. Okay? But you may be asked to solve, which we'll get to, okay? So looking at my graph here, let's talk about our domain. So domain, remember, is my x values, okay? What x values are possible for this graph? X values. Don't overthink it. All of them, right? Infinity. We can have anything we want. Negative, infinity, to infinity. The range is a little trickier. What are all my answers going to be? What did I say? All like what?
All the whole numbers.
All the whole and the nice numbers, all my integers. We represent that in a set notation. And we're just going to list a couple of them. And then I'm going to use an ellipse here to signify that it goes on and on. Okay, but my range is not negative infinity to infinity. Even though this graph goes on and on forever in the y direction, there's breaks happening in between each integer. Okay? My intercept here, this one's tricky. When we think about intercept, okay, we're looking right here. And if you notice, like I'm going to say 0, 0 right now, but really that 0 is symbolizing any or all the numbers in the interval 0 to 1. Okay, so like for example, 0.5 is also going to be an intercept. 0.6 is going to be an intercept. 0.04 is going to be an intercept. Okay, anything that falls in here is on that axis. Okay? In terms of our x-axis. Our y-axis, we only have this one. Okay? Graph appearance, we'll just say steps. All right, so now this last part, this solving piece, this is the piece that you probably should know. I want to see what you can do first. So we're going to test each of these numbers using this function. So here it is. So you're going to plug in your -1 into our funky greatest integer notation, okay, for each of these. So you're doing it 3 times.
Wait,
Okay?
I have to do -1?
For the first one, see the -1? You're going to plug it in right here.
And for the next
So
one,
that'd be,
Then you'll plug a 2 in. Then you'll plug a 1.5 in. So do it 3 times. Then I'll reveal my answer. Yeah.
So if I put -1 in here, would that just be -2?
No, it's just going to be a -1 plus 1, which gives me
0. No. But I thought you had to round out.
only if it's not an integer. See how -1 is already an integer? We just leave it
So for
-1.
this one,
That one you're going to have to
this one
round
has to
down.
go, to 1.
Yep.
Okay.
Yeah.
and if it's on the test, you'll have to take it.
This is whatever.
No, you'll be
Yeah, I'll
okay.
take the
It's
test.
just the first time you've ever seen it.
This
You won't
is
even make
-1.
Yeah, and I'll make up the test, but I'm not making up this section.
You're just not doing it. Put your foot down. Okay, so look at my greatest integer function for this one.
Yeah,
Is that already an integer?
Yeah.
So then my answer is just -1 underneath it.
And then this one, since it's
Bring down your +1.
it would
So what's my
be
answer?
1,
0.
because
Perfect.
That's the closest integer down.
Okay,
This is-
and this
this
is
is not-
2.
Mhm. Yep.
And
Yeah, 2 would just be 2 plus 1. Plus 1. Yeah.
1.5 is just 1.
Mm-hmm.
So it's just 2.
Perfect. See?
But
It's just new.
I think it's the graph.
1.5.
Yeah, the graph is a little freaky looking.
No, it's just like figuring out ways to do it.
Yeah, yeah. All right.
That would just be 2.
Here's what we get for our answers. Okay, my first 2, I didn't have to change my number at all because they were already integers. So -1 stayed a -1, 2 stayed a 2. 1.5 is the only one we've had to round. We got to round down to 1. Okay? Any questions on these? We're good? All right. Last little bit here. We're going to talk about a piecewise function, looking at our graph. Okay? Now, there's two ways you can think about graphing the piecewise function. I'm going to do both of them. Okay? One leads into the other. Okay? Remember, piecewise, we have two different equations that are restricted by our domains. Okay? So if I were to think of this in terms of a chart, that's the first way I'm going to think about this. Okay, so if I'm making a chart here, here's my x values, here's my f of x values. I'm just going to pick some x values specifically that are around the restriction I'm giving you, like 1 here. Okay, so I'm going to go -3, -2, -1, 0, 1, and then because 1 is like, can I call it like a critical moment here in my domain? Because this is where I'm switching gears to a new one. Because that happens, I'm going to write it twice. Because I'm going to do it once for one of them, once for the other equation. And then let me pick 2 more here. Okay, so there's a lot of x values. We're not used to testing this many x values. Typically we did like 5. Okay, but we're kind of testing 2 different equations. All right. Let's find our values up here. So for -3 all the way up until 1, which equation am I using, the top or the bottom? The top one, okay, because x is less than 1. So if I were to plug these in, -3 times 2 gives me -6 plus 3 gives me -3. You could be using your calculator for this. Okay, I'm going to do it in my head and do it pretty fast here, but you'll have your calculator. You can type it in. -2 times 2 gives me -2 plus 3 gives me -1. -1 times 2 gives me -2 plus 3 gives me +1. I have a 3 for 0. When I plug in a 1, I get 5. Okay? Now, here's why we picked the 1 twice. Because when I plug a 1 into my second equation here, I'm going to get a different y value. Okay, so now I'm using the bottom equation as told by my piecewise function here. So if I plug a 1 in here, I have -1 plus 4. I get a -3. Nope, sorry, +3. I plug in a 2. I now have 2. And then I get a 1. Okay, I'm going to go one more, actually, just so that no, it's just because we're almost at our x-intercept here. Okay, so here's a table of values. This is like one way to do it, okay? And now we're going to plot our points, okay? So let me plot the blue points. So my top part, I've got -3, -3. -2, -1, -2, 1, 0, 3. Okay, and now this 1 moment right here. Okay, when we plot our 1s, one of them is going to have a filled in circle and one of them is not. Which one's going to have the filled in circle? The 5 or the 3?
5.
The 5, technically, because my little line is underneath that. I kind of covered it up with my circles. But when it's less than 1 is when it's or equals to. Okay, so I'm going to have an open circle here. A closed circle with my 5, an open circle with the 3. Okay, so 1 up to 5. 1, 2, 3, 4, 5. Filled in circle. And now this is where I stop. Okay, so my blue line is done. We came up this way if we had done more. Okay, so that's the first part of this function. That's the first piece. The bottom piece, I've got 1 up to 3, open circle. 2, 2. 3, 1. And we go this way. Okay. That would be my graph. Okay, so like I said, that's one way to do it. You don't have to write anything because you've already done the second way. I'm just going to erase my graph real quick and show you the second way to do it if you're someone who Maybe you didn't follow that version. That's okay. Personally, when I first learned this, I did not do it that way. Okay? What I did was I looked at my piecewise. I saw that 1 is that moment when things change. So I went to my x value 1, and I just put a little dotted line there. My top equation I knew applied to everything on this side of that line. So I took that equation and I graphed it. So my starting point was at 3, 2, 3. My slope is up 2 over 1, but I knew I had to stop there. Oh. So I now just brought my line on this side. Down 2 over 1, down 2 over 1, down 2 over 1. That dotted line is also where I knew I had to pick up with the new line. So in theory, I would have started here, and then I would have gone down 1 over 1. So that would be the first spot that I saw my open circle. Then I would have just kept going, because now I know I'm on this side of my piecewise. Okay, so we should get the same thing both times. Okay, you choose the method that works better for you. Okay? All right. That is it for our notes. When you come back in, I'll have a screen up here with everything that we just talked about that you can take a picture of, okay? Because I won't make you copy all of it down. Yeah.
Is that Quizlet graded?
The Quizlet, no. Yeah, so when you guys come back, there's a Quizlet in here. Personally, I'm not going to look at it. It's just in there if you would like to practice the greatest integers, okay? But that is not graded. That is more a resource if you would like to practice that, okay? But then the rest of the time is to work on your homework, okay? That was it. Good job, guys. Chapter 2,
What was
almost
the
done.
pages from yesterday?
14 and 15.
Dude, so this game's gonna suck today. I really wanted a nice Friday to be off. This is like the second Friday we've had a game.
So it was rescheduled for today. It wasn't yesterday's game that got rescheduled?
No, it was supposed to be on Tuesday, but then the hockey championships we had this. We moved it and got moved to today.
Who had to go to hockey championships?
Our
Fox
best
Chapel?
attack-
Oh, okay.
Yeah, Fox Chapel. Our best attack been one of our really good teammates, starting defender, senior, 2 seniors.
Yeah, that makes sense then. That is frustrating though.
They're like
Tuesday was like
I think it
warm too.
4 or 5 stars. I think it was.
Yeah, okay. That makes sense. Guess you kind of have to do that.
I'm
Yeah.
so confused on like the even and odd.
So even and odd, just think symmetries. So,
So odds like origin.
Yep.
Evens y.
right. And there is no XY. There is no even or odd for the X. So you're only thinking about those two. If it isn't either of them, then it's neither.
Okay.
Okay?
you gotta do.